Hey guys, it's Obi here. We're going to continue on talking about gears today. So today is day 5 and we are going to start talking about gears and RPM and torque. So we know how to calculate our gear ratios and we know how to find the number of teeth on a missing gear or pulley or whatever. But today we're going to try to understand how RPM is going to be intertwined with our gear ratio. So the important thing for us to know is that gear ratios and RPM are an inverse relationship. And this means that as the gear ratio increases, the output speed will decrease. And as the ratio decreases, the output speed will increase. So our formula to find this is pretty similar to what we've been doing. So we are going to do our gear ratio, but the difference is our input RPM is our drive, and our output RPM is our driven. So what we have to realize is that when we were doing just the gear ratio, it was driven over drive. But when we are actually finding RPM, it is drive over driven. So that's the key. That's what you got to remember, okay? So I want to do an example for this one. And our example is, how fast is the output shaft spinning if the input shaft is spinning at 1200 RPM and the gear reduction is 3 to 1? Now, I want you guys to understand that when we're doing this calculation, we have to understand what our numbers are and we have to be able to identify in a word problem what we're looking for. So what I mean by that, let's go ahead and highlight it. So if the input shaft is 1200 RPM, we can find the input RPM right there because we know our input shaft is going to be the input into the gear set. Now, I would say that the input shaft is probably how much power the motor is actually producing, but it doesn't specifically say that. So we know it's spinning at 1200 RPM, so we can put in our input RPM 1200, and we know our gear reduction is 3 to 1. And that means that the one variable we don't know is our output RPM, our driven. So we have to do our cross multiplication. So I think we're all pretty good at this point. So we're going to cross multiply 3 times x is 3x, and 3 times 12, and 1 times 1200 is 1200. So that brings us to 1200 over 3x. So if we divide 1200 by 3, we get an output speed of 400 RPM. So because our gear ratio is an underdrive, which means it's a number higher than 1, we know that the RPM is going to be lower on the output than the input. Now, if this was a lower than 1, like a 0.7 or 0.6 or whatever, we would know that our output RPM should be higher than our input. And that's the way for us to check it. If you're not sure, if you screwed up something with your math, that's what's going on. So, I mean, if this is lower, this should be higher, and it's inverse. Okay, they're backwards. Okay, I think that's going to be pretty simple for you guys. That is half of your assignment for today. So the other half we want to talk about is gears and torque. Okay? So when we talk about gears and torque, it's a little bit different. So with an underdrive ratio, we will increase torque. So the higher the number, there we go, the higher the number, the more torque we're actually going to get. So as the gear ratio increases, the output speed will decrease, but the torque will increase. And then as the gear ratio decreases, the output speed will increase. So our math for this is probably the most simple one we've had this whole time. So it's going to be our gear ratio times our input torque equals our output torque. That's all you have to do. Pretty simple. So let's do an example for this one. And again, we'll say how much torque is applied if the engine produces 100 foot-pounds of torque and the gear ratio is 3.58 to 1. So let's make sure we highlight our information. There we go. So we have 100 foot-pounds of torque, and the gear ratio is 3.58 to 1, right? So we can type this in and we can say, okay, so our gear ratio is 3.58 and our input torque is 100 foot-pounds, which is right here. So what is our output torque? So a 3.58 gear ratio times 100 foot-pounds of torque gives us 358 foot-pounds of torque. So there we go. So anytime we have an underdrive ratio, which is going to be numbers higher than 1, we are going to have a number higher than what we started with. Anytime we have an overdrive ratio, which is numbers lower than 1, we're going to have a number smaller than what we started with, okay? And remember, on RPM and torque, if it's a direct drive, if it's 1-to-1, the only time this applies is if it is exactly 1-to-1. But if it is 1-to-1, our output RPM and torque does not change at all. So I hope that helps. You guys, make sure you do the assignment and make sure you click the turn in button when you're done. That really helps us know when the assignments are completed so we can grade them, okay? All right. Thanks a lot, guys. Talk to you later. Bye.